Welcome to lesson 7142, composing trigonometric and inverse trigonometric functions. Okay, when you take the function and its inverse or opposites, so the sine inverse, let me put the pencil on, sorry everybody. The sine inverse or any inverse, a ratio has to go in here. And when you take the function value of it, that will give you the x back. They undo each other. It's like taking x squared and then take the square root of x squared. If you square x or take the square root of x squared, you get x back. So they work in opposites. They undo each other. When you take the sine of an angle, you get a ratio. When you take the inverse sine, you get an angle. So whatever x is, sine of an angle, this would be an angle, and out here would be a ratio. And these would be angles out here on the bottom row. So sine and inverse sine, cosine and inverse cosine, tangent and or arctangent, don't forget about the arcs. They undo each other, and you just get the x back. Okay, now these are the algebraic properties of these functions. So notice the sine inverse is on the inside of all of them, and we're going to use these using a unit circle. And remember, the cosine is the secant flipped upside down. The cotangent is the tangent flipped upside down. They did not get rid of the radical in the denominator for the second line, but we're not going to worry about that right now. Okay, let's look at our unit circle here. I know we have x as the height, but we're just using x as a general. We're not using it x as the height. We're just using x as the number. Remember, theta equals the inverse of sine x, where x is some number, not necessarily the height, which should be y. So we're just looking at it like this. And we're going to use the letter S for this side. We know that according to Pythagorean's theorem, s squared plus x squared equals 1. So s squared equals 1 minus x squared, and then s equals plus or minus the square root of 1 minus x squared. And this is how we get the inverse sine of the sine function for, I think that was the first one, listed on the previous page. So now what we're going to do is replace the s here at the bottom. We're going to call this, not my marker, I'm sorry for being a marker. We're going to call this 1 minus x squared. And then for the 6 trig functions, the sine is going to be x over 1, which equals x. The cosine is going to be the square root of 1 minus x squared over 1, which just equals the numerator. Let's do the tangent over here since it goes with the cotangent. The tangent is going to be x over the square root of 1 minus x squared. The cosecant, remember the cos go with the non-cos, is going to be 1 over x. The secant is 1 over root 1 minus x squared. And the cotangent of x is going to be square root of 1 minus x squared over x, where x is some value. And this is how we proved the ratios on the previous page. Okay, when it comes to word problems like this, you're really going to want to draw a picture. So what we have here, the bottom of a 20-foot replay screen is 45 feet above the playing field. So you're sitting in the bleachers, and the bottom of the screen is 45 feet, and the screen is 20 feet high. So this is 20 feet, this distance. So some TV screen. And you have this angle from your point. So you got theta and theta 2. As you move away from the wall, the angle formed by the screen at your eye changes. There's the distance from the wall at which the angle is the greatest. What is that distance? Okay, so let's calculate. All right, so the angle theta is going to be the tangent inverse of 65, the height of the screen, divided by x. So 65 is height over the distance, where this is x. Now we're using y and x again. Minus tangent inverse 45 over x. When I put this into y equals, and get our distance from there. All right, we're going to hit second graph. And then what's funny is as you get higher, in the 50s, so you don't even have to worry about setting a window or looking at the graph. You just keep going down. And I got into the 50s. And when I got into the 50s, really when I got to about 48, the numbers got to 10.4. And then 55 was 10.447. So I wasn't sure if this was the high. So what I did was remove my right arrow into the Y column, and I saw that 56 was 10.469, 55 was 4.474, and 54 was 0.475. 53 was 0.473, and a bunch of other numbers. So it looks like around 54 feet. Around 54 feet is the optimum distance. And that one we just had to put in the calculator and kind of mess with. And so what that means in real life, if you're 54 feet away from the wall, that's the maximum distance away to see the entire screen. If you're closer than that, you're going to have to move your head to watch the entire screen. If you're further away, you're past the viewing distance and you really start to work your eyes. If you have good vision, you can get further away and still see the whole screen, but you probably won't see it as clearly as the best distance is, which is 54 feet.